Alright, good morning. So right now I'm going to go over trigonometry review or diagnostics to see where you're at in the trig section. This is our first section. This was chapter 2, trig review. Okay, so I'm going to be going through each section that we had gone through back at the beginning of the year. Now, there are 7 different sections, generally a page per section, and I'm just going to do the main questions. And I would try the questions first. And you can pause the video and skip to the questions that you don't get, or you can go through it at the same time. But I would try each question first and then see how I did it. Okay, so this first question, section 1, we looked at what sine, cos, and tan ratio are. Okay, so you always get a right triangle in grade 10. That means that one of the sides is a 90-degree angle. So we have a 90-degree angle over here. We have some sort of angle here and some sort of angle there. We're not sure. And but we do know the side lengths. We know this is a 5, this is the 7. And then this one, the hypotenuse, which is opposite this one, is always the largest one. Okay? And that one's at 8.6. So it says find the sine, cos, and tangent ratio. Okay? So the first thing we always have to do with these triangles, if you remember, is you look at your angle that you're trying to find, or the angle that you denote that you're going to use. And that's going to be this x, because that's the only one. You never use the 90-degree one, so you're going to use this one. Okay, so let's mark up our triangle. So over here, if we go across, this is O, because it's opposite your angle. It's the only one that's the furthest away. Okay, this one is always h. The largest one is always your h, or your hypotenuse. Okay, and that's always opposite this square here. And then last of all is an A here. This is adjacent or beside your angle that you're choosing. Okay, so we have O, A, and H. We have 3 letters, and there's really 3 combinations that you can always talk about with a ratio. Ratio just means a division. Okay, so it means when you take 2 sides and you divide them. Okay, so sine, cos, and tan really just mean those two, and those two. Okay, so the sine ratio is O over H. Okay, and the formula you always use is sine theta, and theta is the same thing as your x there. It's your angle, is equal to O over H. So they say, what is your sine ratio? They just mean what's your O over your H. And we look at ours as O over H, or 5 over 8.6. So our ratio is 5 over 8.6. That's all they look for whenever you see that word ratio. Okay? Whenever you see that word ratio. So cos here is A over H. Very similar. Let's write it in a standard equation form. Cos theta is A over H. Okay? So let's look for A over H. 7 over 8.6. So that is our ratio there. It's that part. That part. Okay. All right. And last of all, we want a tangent ratio. Tangent just is the same thing as tan, which is O over A. So our 3 main ratios: O over H, A over H, and O over A. So here, let's write it standard. Tan theta is O over A. Let's see where O is 5 and A is 7. Okay. So 5 over 7 is the ratio for those 2 sides of this triangle. Okay. All right, so let's go on to question 2. Here's an equation, standard. Sine, so it's sine theta is O over H. Sine theta is O over H. So what's our O? It has to be 7. What's our H? Has to be 8. So sine A is 7 over 8. It says label this triangle here. Okay. So they don't have an X like the last question, but they do say that A is this corner right here. Okay. So that means that's really our X. That's our one that we're using, or we denote that we're going to use. So here, let's just go ahead and label our triangle like we did the last one. So O is opposite, A is beside, adjacent, and then H is always opposite that square. Okay, so sine theta, let's just write that underneath. Sine theta is O over H. Okay, O is the top one, 7, so O is 7. And then H is the bottom one, 8. 8 there. Okay, so we labeled the triangle 7, 8. We don't know what this is right now. but that's all it wanted us to do. Okay. Now section 1 is almost done. That's really what we did kind of that first class, but what is tan 15 is the next question. What is tan 15 degrees? And what is that really asking? It asks if you have a triangle where that is 15 degrees and that is a right angle. It's asking what's our equation? Tan is usually O over A. So tan 15 is O over A. So they're saying what is tan 15? It's O over A. So it's whatever side length this is divided by whatever side length that is. Okay, so just that divided by that. So what is tan 15 degrees? This question is just asking for you to use the calculator. Tan 15, we can go tan 15, enter, is 0.2679. 0.2679 is tan 15. So that's the answer it's looking for, just that part there. Tan 15 is 0.26. So it means that if you take this and divide by that, you'll get 0.2679. Okay, every time if you have a 15 degree and a right angle. Alright, so that was just kind of like how to use the calculator type question. Now this one says find the angle if tan theta is 5 over 4. So this is a theta here, same thing as an x. So if we look, we have to label our triangle. That's O, that's A, that's H because it's across from the square there. So tan theta is 5 over 4. So what is tan theta again? We have to look at our original equation. It's O over A for tan. So that means the 5 is the O and the 4 is the A. 5 is the O, the 4 is the A. Okay? That looks like 0, 5, but it's just an O. That's side length of 5 and a side length of 4. That's how long that line is, Okay, find the angle here. Okay? So how you do that is you actually have to solve for theta. What is theta? It's getting theta by itself. Right now it has that word tan beside it, so let's get rid of it. What's the opposite of tan? The opposite of tan is tan inverse. So this will change to tan inverse of 5 over 4. So I did the opposite of that, and then I did it to the other side as well. So theta now is equal to tan inverse of 5 over 4. Okay, so let's type that in our calculator. I get second tan, and then 5 over 4, and I close the bracket. I get 51.3 degrees. So my angle here is 51.3 degrees. If my side length there and there is 5 and 4, it has to be 51.3. And you always just have to use the calculator for this type of question. So when you're trying to find an angle and you have side lengths, you always use that inverse button. Alright, section 1 is done. That was our first day. And now we move on to section 2. This is not an L, this is an angle. It means determine the angle G and the angle J to the nearest tenth. Okay, so we're trying to find an angle just like the last question. Angle, angle. We're trying to find an angle just like the last question. So when you got to do that, you got to use that inverse button just like we did last. So here we have angle G, angle J. Okay, where do we go from there? We know that we have numbers there and there. We don't want to use H, which is across from the square, because there's no number there. Okay, we always could find that H by using Pythagoras, but why would we do that when we already have two pieces of information? So let's not use Pythagoras. Let's just look at the 4 and the 5 there. Okay, so let's label it in respect to G first. So let's just look at G, not J, just G. So G, let's label the triangle. This is opposite G. This is adjacent to G. So here we know O and A, so that means we have to use tan. Okay, we found out that we have to use tan, so let's write the equation that we know for tan, O over A. Okay, so our theta is G here. So I'm going to go ahead and write tan of G is, instead of O and A, let's write the numbers. 4 over 5 And we have to find out what g is. So when you're solving for the angle, you have to do the opposite. So g is the inverse of 4 over 5. We're looking for an angle, so we're going to hit that inverse button. Okay. So overall, we're pretty much done. Calculator time. 4 over 5, and we get 38.7 degrees. Okay. So that means this angle has to be 38.7 degrees for this triangle. And when we do that, we get that answer. Now we got to move to angle J. They want also angle J here. So let's look at angle J. So I see angle J there. The only problem is this is no longer A, because we're now looking at this. We're looking at just J now. Just J. We're forgetting about G. This is no longer A. Okay, get rid of it and change it to an O. Get rid of it and change it to an A. Okay? So that changes. The H doesn't change because that is always across from that. But it changes depending on what angle you are looking at or choosing. So here, now it's still O and A, so we know we're still doing a tan. Okay? And now we have theta is O over A. So it's really the same procedure. Something's a little switched though. Theta this time is J, so I'm going to go tan of J. O this time is 5. A this time is 4. There you go. We're looking for an angle, that J, so that means we have to do that inverse button. So overall J is equal to tan inverse of 5 over 4. Okay. Okay, so now we just got to do calculator work. Let's hit that inverse tan button, 5 divided by 4. And that gives us J is equal to 51.3 degrees. Circle that. That means this, in this triangle, has to be 51.3 degrees, no matter what. If that side length is 4 and that side length is 5. So, one more thing to notice here is if I take 51.3, add 38.7, and add our square, which is always 90, I will always get 180 degrees. Every triangle adds to 180 degrees. Alright, so section 2 is almost done. That's kind of what we did, just looked at using that inverse button. The second one is a real world problem. A 10-foot ladder leans against a 7-foot wall. Let's draw this. We got this wall right here. This is 7 feet. And then this 10-foot ladder rests against it. Okay, this is my ladder. There we go. And I'm going to say that's 10 feet ladder. What is the angle with the ground? So it wants to know what's that angle there with the ground. So one thing you can notice with this is it makes a triangle like that. So I'm going to just redraw it more simple. Put a little 10 there, a little 7, and a square there. Okay. We know that a wall makes a right angle with the ground, or generally it should. And our theta is here. Okay. So now we have a triangle with two pieces of information and an angle that we're using. So here let's denote our sides. We have an H, we have an O, and we have an A. So here we're using an O and an H side. Okay, so we're using O and H this time. We're not using the A. So the one we're going to use is sine. So sine theta is O over H. We know that we're going to have to use sine. So let's go ahead and put down this equation. Okay, now let's fill in our O and our H. O is 7, H is 10. Sine theta is 7 over 10. And now we got to solve for our theta, because that's what they want. When you're solving for an angle, you always got to hit that inverse button. So theta is sine inverse of our 7 over 10. And so that means sine inverse of 7 over 10. Oops. It's 44.4. So our angle is 44.4 degrees with the ground. Okay? And there's a real world problem done. It's really the same as a normal problem, but you got to change words into a picture. Alright. So that one's done. Let's move to section 3. Determine EF length to the nearest centimeter. Okay? So it's another triangle, because all these questions are triangles with right triangles. So let's denote each side. We have an H. We have an angle, so the opposite of that is this one. And then we have A over here. Okay, So now determine EF. What does that mean? It means determine the side length from E to F. That's from here to here. So it wants to know this A side. Okay, so it wants to know this A side. So to the nearest centimeter. Okay, this I'm going to guess is centimeters, so let's put centimeters there. So that means we know this side, and we want to know this side. Okay, so that means we got to use this and this, which means we got to use O and A. What equation uses O and A? There's only one, and that's tan theta is O over A. Okay, so we have to use that one for this one. So tan, our angle is 20 this time. This time we don't leave it blank. We can fill it in with a number. Tan of 20 is equal to O over A. Our O is 3.5, and our A is, well, it's A. We don't have a number there, and that's actually what we want, so we'll leave it as the A. Okay. Okay, so we have one variable we don't know, and we know everything else. So let's solve it for this variable. We got to get it by itself on one side of an equation symbol. Okay, so that means you'd think you want to get rid of this one, but you're not actually going to get rid of that one. You want to get this on the top of a fraction. You never want your variable on the bottom of a fraction. So what we're going to do is we're going to move it to the top. So we're going to times by A to both sides. Okay, that effectively crosses that out, and you're left with A tan 20, or A times tan 20, is equal to 3.5. My whole thing there was just to get it out of the bottom of a fraction. And now that it's at the top, it's easier to do your math. So we have A times tan 20 equals 3.5. So I got to get rid of tan 20. How do you do that? I'm timesing it, so we got to do the opposite, which is divide. Okay. So if you divided both sides by tan 20, that would cancel out, and you'd be left over with A equals 3.5 divided by tan 20. Okay. A lot of people do a step where they take this step and they go straight to this one, just by swapping your tan 20 and your A. Okay, that's another method that happens. Then it's just A is 3.5 over tan 20. Alright, let's type it in our calculator. 3.5 divided by tan 20. And we get 9.6. So 9.6 centimeters, and it wants it to the nearest centimeter, it said at the beginning. Okay, so that's the nearest centimeters right there. So you look there, and then you look one more just to see if you have to round, and we do, because that's above 5. So let's round. A is going to be 10.0, or just 10 centimeters. That's to the nearest centimeter. Okay. Now this next one, you are 51 meters from the base of a tree. The angle to the top is 32 degrees. How high is the tree? Okay. Well, you know in the question it has a tree. So you can draw your tree. There's my tree. Okay, you know you're standing away from the tree, from the base of the tree. So a person's standing somewhere. Okay. And we're looking to the top of the tree here, and it's saying the angle to the top is 32. So that means there, the angle to the top. And it's saying you're 51 meters from the base of the tree. So in this question, we're going to assume the person is not standing. We're going to assume they're laying on the ground so that they don't have this height as well. Okay, so they're laying on the ground, just so that we can get the full height of the tree. Okay, so 32 degrees and 51 meters from the tree. Okay, how high is the tree? So they really want to know what's from here down to here. Okay, so if we draw this more simply, because every word problem will be just a normal triangle problem, they want to know what this is. And they know that this is 32, and they know that this is 51 meters. Okay, so we want to know what this side is there. Okay, so how do we do this? Well, let's look at the triangle. That's an H, that's going to be an O, and that's going to be an A. So we're going to have, we want to know this, and we know this. So OA. So we're going to have to go tan theta is equal to O over A. Okay, now let's fill in our numbers. Our theta is 32. Our O is, well, it's O. And our A is 51. Okay. Overall, this is different than this one up here, because before we had the unknown on the bottom of a fraction. So this is the other case, where your unknown is on the top of a fraction. Okay. So in this case, we got to get O by itself, but it's not on the bottom of a fraction, so it's already happy. So let's get rid of this bottom one. Okay. Right now, this bottom one is being divided, so let's do the opposite of that. Let's times by 51 to both sides, and we get, those cancel out. And then we get 51 tan 32 is equal to O. And what I usually do is I usually write it this way, because I always like my variable on the left side. So 51 tan 32, 51 tan 32 is 31.9. That's what I got. That's the opposite side, that's this side. We're going to use the same unit that they use there, 31.9 meters. Okay, so that's how high the tree is, 31.9 meters from the ground. If it's 32-degree angle and you're 51 meters from the base of the tree. Okay. All right. I'm going to stop the video there, and we'll do part 2 in a different video. Thank you.